Sorry about the last stream, and I realised the microphone was very quiet. I also wasn't showing you the Explorer windows. The resolution was very bad as well. So I've corrected all those things, and this is another test stream really to see whether the changes have negatively affected any of the stream, because I've upped the resolution, and obviously I've affected those other changes, so now you'll be able to see the window. Speaking of which, if you look at my console here, I've created a folder called fast food, and I'm going to show you that now. There it is. It's an empty folder, as you see. Now we're going to make a game called fast food, a very simple game. It's going to be a face at the bottom of the screen, and he's going to munch burgers, but he's not going to like vegetables and other such yucky stuff like that. You might have played an old game like that in the old Atari era, or you may not have. There's probably plenty of other systems with games about fast food as well. But this is what we're going to do tonight, and I'm going to do as much as I can. As I say, I'm going to start it off again saying I am still a beginner. I've had many years coding experience on and off, no training, just reading books and studying on my own. And sometimes it helps you beginners to see an angle such as mine, because sometimes the experts can explain things and you don't have a clue, and they don't realize that you don't understand most of the words that they're saying. So I'm going to try and keep it not like that. I'm going to also try and share my knowledge where I do have deep knowledge. One day I hope obviously there'll be live viewers, and that you'll be able to ask me questions while we actually code. Let me see, I'm not actually on my stream. I should check that in case there is any viewers. Sorry about this. And it appears that there's not, so that's good, and also bad. So right, okay, where was I? So anyway, we've got the empty folder fast food, right? Don't need that open. That's just to show you it. We're in that folder in the command line, and we just want to create a sprite. We're not going to worry about making a main menu yet, doing all that. We're going to worry about that another time. We just want a sprite on the screen, and that's it. We don't want a character. We can write hello world. We've already done that. There is something else you can do if you only want your sprites to be 8x8. You can use what's called UDGs, user defined graphics, and you can set up your own character set in a way like ABCD. It's part of the character set of the Spectrum, or every computer has its own character set. Spectrum uses one that's very similar to ASCII, and again, it can be looked up on Wikipedia. It's very, very simple when you get your head around it. So we're using basically an ASCII subset, but we're not going to be worrying about text, and we're not even going to use UDGs. UDGs are good though, because you get a whole bunch of space. I can't remember the exact amount. We'll tell you that. It's in my book, my reference book, but one day I'll have that available to me. But basically, there is like another at least 20 or so character spaces. You can create your own 8x8 graphics and just poke them straight in to there and use them as if they were text. And obviously that's very handy, especially if your game's only going to have 8x8 sprites. But you know, 8x8 is very limited. You could only have maybe, not very many games can run with just purely 8x8 sprites. It can be a very poor game. Might be good for you to practice with, but I liked to jump straight into making a sprite writing routine, because the Spectrum has no sprite routines whatsoever. You have to write your own. As far as the Spectrum is concerned, it's basically a console. It's one of these. it can do 2 colors per character space. So it can do the background, which is called paper, and the front, which is called ink. And excuse me. Yes, so that's a little bit about that. So when we want to, let's start by making the sprite. And the funny thing is, you could use GIMP or you can use ZX paintbrush. There's a lot of spectrum specific paintbrush style applications which I use heavily, and I will be showing you for sure. I wouldn't suggest trying to make sprites this way in most scenarios, although I do use it. It's sometimes easier than using a art editing application. What you need to do is you think about a sprite. Let's make an 8x8 sprite call it cross, right? It's going to be a crucifix. Now 0 represents no ink, and a 1 represents ink. Imagine that for a second. You need to define the byte. As always, it's not. I haven't saved this file. That's why it's not highlighting. Let's save. It still doesn't show you this window because it's in the save as window. But basically, I'm just saving the file. It's easy, and I'm calling it. Saving it into my fast food folder, and I'm going to call this fastfood.asm. We want an 8x8 sprite, and we want it to look like a cross. So if we put 8 zeros like that, that's actually 8 bytes already. 8 bytes, not bits. There's 8 bytes, so there's 8 bits in every byte. So there's 8 groups of 8 there, and that's defined byte. So we've just defined 8 bytes, but they're all 0, so that's a blank square. And also, it doesn't look much like a square. Like when you look at that, you have to be a clever clogs to understand that that's a blank square. So the best way, that's a decimal notation, yeah, 0, a base 10 decimal. But you can also represent a number in binary, which is base 2. So that would be a prefix for the percentage sign, and then 8 of them. That's just 1 byte. So if we wanted to do 8 blank ones are there, we can duplicate that 7 more times. So we've got 8 of them. There we go. We have an 8x8 bitmap right there. Each bit this time represents either a blank pixel or a filled pixel. Okay, sorry. So to make a cross, let's just do it very basic. We don't need it good, but we'll do two ones there, like so. And then this whole byte here is ones. Okay, so you can actually see it's like a cross. Yeah, if you look closely, and that same applies. It gets more complicated when you want. That's the size of a character cell, so that's very simple. We could put that into a UDG, but let's say we wanted to make a face, right? And this is going to be our player, and an 8x8 is too small. We want 16x16. That's going to be big enough for us. Now, of course, I am going to show it again later. I can't do it now. It's not rigged up, but there's a software called ZX Paintbrush, and you could draw this face and export it in this exact manner. You can set up the way it exports so that it will fit exactly with your algorithms, because this data could be laid out any way you want it, because it's all about how you then write an algorithm to read that data and put it onto the screen. So it doesn't matter how you represent it. You could have it backwards, or you could do a whole number of things with it. Particularly when you have more than one character cell involved, like with this face. We're going to have, there's our first one. Okay, but to make things easier, just to visualize, if we left it like this and we drew some ones in there, that is now a 16 by 8, and it has 2 bytes width, notice. Now again, I could have written that, I could have gone like this if I wanted to and written them all in a line, but it's just easier to see like that. You can see now, let's draw the face in. Let's not make him smile because it's actually a bit easier not to, well no, we can't have him not smile. He's got a smile. So we'll just pop a little grin at there. Let's give him a flat head. And why not finish him off, give him an outline. Okay. Okay, it's not a very good sprite, but you know, as I say, you're not going to be actually creating a sprite from scratch in this manner very often. His little face. And he's going to be right at the bottom of the screen, ready to munch. So now we've got our sprite bitmap data. Let's make it, for argument's sake, let's just let's leave it as a 16 by 8, yeah, or 2 by 1 byte. Well, it's 2 width, 2 byte width, 8 lines. Okay, so that's our data. We're going to leave that as convention dictates at the bottom of our file. And we're going to, what I do is put some nice big comments. Data begins. Now you can easily see where your data starts and your code ends. Your logic code will go here. Speaking of which, we're going to need an entry point, as I described last time. It's just a constant, and it's 32768, which is the start of our memory, where we want this program to start. Is org entry point. That's actually telling the program to start from that amount. At the very end of all code, including the data, indented entry point, end entry point. Again, I labeled that whatever label I want. You know, you could call that EP or entry, whatever you want. Entry underscore point. It's a constant, so you capitalize it. That's the normal convention of programming that I've encountered. And same with the underscore. When you have everything capitalized, you put a space with an underscore. Just the way it is. You'll learn these things as you go. And now we're ready to actually create some code. So that's where to start, isn't it? We always load A, basically at the very start. It's almost always the first thing we do. I think I'm going to open up one of my other projects to remind myself of this beginning here. And I'm writing this in hex, DAF. You're going to have to learn hex to do this programming, although it's not essential, because DAF in hex, let me work this out. is 3503, so you could just call 3503 to clear the screen and open channel 2. But it's easier to remember DAF. And the OX prefix just means it's a hexadecimal number. Okay, I'm going really slow here, but you know, no, I'm going to comment it actually. Clear screen, open channel 2. You basically do that one time at the start of your program. I hate that. Now this will run, but nothing will happen. You know, it'll just clear the screen and then exit. But if you wanted, you could put a main loop here that does absolutely nothing but jump back to the start of itself. So what's going to happen is it's going to enter here. It's going to call this function, which is built into the spectrum at that address, which does that function there. Then it's going to skip down to here, see that it wants to jump to main, it'll find main, and it'll just keep doing that over and over. So if we wrote something here, it would happen once, and then the whole program would just hang waiting for you to turn the computer off, which is fine. Sometimes you need that to happen. What have I done next? X or A? Well, all that is just a super fast way of doing LD A0. Right? It's the exact same thing. So X or A just uses less of the CPU. But it only works for 0. And I'm going to explain a lot about XOR as well, and OR, but it's a bit far a bit further ahead, really, that one. But what it is in a nutshell is it's a bitwise operation. So if you imagine you've got, if A was happening to be that binary number there, but you wanted it to be 0, you could do LDA 0, right, and it'll just wipe it out, but that takes more power. So this way, checked everything as an XOR. So it's really hard to explain without sharing it on the screen. In a nutshell, it means that it changes all the bits to 0. It's not as useful XOR as and OR, in my opinion, and you'll very quickly get used to how they work when you see them in action. So let's just leave it at that for now. Let's just A equals 0. Let's keep it that straightforward. Okay. And why do we want A to equal 0? Because we're calling the function that sets the border color. So that's the only reason we want it to be 0, which is black. So we're giving it a black border there. So let's call that function. It's 229b memory, but I will check. Yeah, it is. So set border color to A. So in fact, let's take a look at it in action quickly. Main loop, jump main. Down in my terminal, I'm going to call my compiler. I'm going to tell it to do tap bass, which is, as I said before in the previous video, creates a tap file with the basic built into it to make it begin running immediately without any input from the user. I have to write file name for the source file, and then the file name for the output, which is fastfood.tap. And there we go, successfully compiled. It would have given me an error otherwise. Now, I'm getting told there's an error on my stream. I don't know if it works or not now. I'll have to check it back later. Sorry about that. I'll just try it later. I'll persevere for now and see if it worked. So anyway, it would have given me an error. I'm going to do that, which just opens the folder that we're in. You should be able to see that now because I've set it up so you could have just called fast food, but you could double click it as well. And as you see, we've got a black border there. So you can't even see that against my screen background. And it's a bit boring with X or A. That's a bit advanced. We don't need it. Let's go for load, which we already know. So we're going to load A. But if you don't know about spectrum colors, you're probably going to have to read about that as well. But there's only, I think it's 8 for the border. 0 to 7. And 7's white, which is the sort of horrible grey color you see on the spectrum. So let's go. I think 1 is red, or it might be blue, but let's put 1 in A and just run this. Oh, so I've changed this to LDA 1. And then I'm gonna invoke item fast food. Oh, it's still black. That's not good. Did not expect that. Oh, I didn't compile it, did I? That's why. Idiotic. Right, so the same command to compile and run it, and we've got a nice red border. And we'll go back to blue, like I said. Compile, run. Blue ski. Yeah, that's all well and good, you say, Dave, but where's our sprite? We want to draw that bugger, don't we? That's what we want to do. And a little sneak peek of a game I'm working on. Well, no, the draw code's not in there. You can split them up. This is just a small chunk of the file. Yes, as you can see, it does get a little bit complicated, but you soon get your head around it, is like what I'm trying to say. Let's begin to draw a sprite. Let's make a subroutine called draw sprite. And that's going to draw our face. The spectrum memory is very, very strangely laid out. And I've written a piece of code already which fixes that. And I'm going to load it again so that we can work through it. It's much easier than trying to start it from scratch. In fact, I'm going to copy my entire utility folder. So now I've got a copy of that in this games folder. So it makes it even better for me. That's why I wrote these subroutines in this manner so that I can reuse them. And there it is. Sprite tools. Sprite tools, and it's in fast food /utility util. Okay, so that's very important. I haven't taught you yet. You have to. Well, you don't have to. You could have it all in this file if you wanted to. It's a very, very long file and unorganized. I like to organize it because I've worked in object-oriented languages much more than I have in assembly languages. But so if we do include, and then it assumes you're already in this folder. So we just need to do utils which is the folder name that I mentioned, and then sprite tools.asm. That's saved. Now this folder that I've already created, this file, sorry, is now available in my fast food game. And this, you will notice, has a draw sprite function already in there, okay? And I'll be able to make this available to anyone, but we'll be working through and making a better version of this anyway during streams regularly, so we're always improving. This is quite a good one though, which draws a sprite of any size, which is why it's a little bit more complicated than it needs to be, but it's fine. It'll draw a lot of sprites on the screen at the same time without the spectrum worrying. So let's use it. So as you can see, it draws a sprite of any size. Inputs, HL, sprite bitmap, IX, which is another register I didn't mention before. You've got the IX and the IY registers, 16-bit. It can't be used for every single register operation that the other registers can, but they can actually do some that only they can do. It's quite complicated. Again, you just have to learn these things, which is what we're doing here. That's going to contain the properties, and they have a certain order they need to be in. If we look, we're using IX plus 2 and IX plus 3, so it's going to need data to know where to display the sprite, its position, and how big it is, things like that. It doesn't just know that. Here I've written a summary of how that data needs to be laid out for this particular script to work. But also you'll notice, if you look carefully, call yx to pics, and there's no yx to pics. So what's going on there? Well, unfortunately the way I set it up, I actually put that into screen tools, something called screen tools. And this is where the nitty gritty is actually done. And to be honest, I copy and pasted this from another tutorial made by Jonathan Caldwell. His link is on my YouTube channel to the book, where you can download it for free or any amount you would like to pay from an official source. It's an excellent book. It explains lots of this. I haven't written this directly. This has been modified. I've changed it. Shortened it and made it do what I needed it to do. Before, it only catered for one particular size of sprite. Now it doesn't, but these two are very important. And RRA is a rotation of bits. What that basically does is divide the amount by 2 each time. Again, if you're a mathematician, you'll understand exactly why, but if you rotate a bit to the right and you don't store and you lose the bit that leaves on the right, then you will divide a number by 2, sorry. So this is divided by 8. And the memory is so hard to explain. You basically, there is a way of doing it, but it would require me going into basic. But if you poke a black pixel into every pixel in order in the memory, it actually draws a line, and then it skips 32 lines and draws that line, and so on. Then it goes back up. It's a very strange order. It should just be in direct straight order, in my opinion. That would make writing code like this much more straightforward. But what this is basically doing is shifting bits about from the position amounts. It takes the Y position and the X position. Takes the Y position and the X position into the H and L register. You put that value in there. So if you're in X position 10 across and 10 down, you're down here on your little grid. That's what your y-x position is, and it will convert that into a screen memory address. So therefore, all you have to do is there poke the certain bits, as in, you know, this value at the right address, and then you get the sprite on the screen. Just for fun, so you know that I'm not completely idiotic. I'm going to show you this one I was working on for a friend, for a joke. This is just a joke to make him laugh, really, for his own YouTube channel. And I'm going to run that quickly just to show you how far I've got with that one. It's only taken me a few days. One moment. Yeah, as you can see, I've made a menu here where you can choose the keys. It's got a little copyright, and I'm going to choose WASD. Some crappy music I made, and there he is. He's an animated sprite. There's some cars. He's got his hat on. The score has increased. The money's gone down when he buys his hat, and this is roughly as far as I got. It transitions to the next screen. Stuff does work. Here we go. The object of the game in this screen will be you've got to go and kiss the ladies in time. But this is a work in progress. As I say, it's just a few nights' work, really. It's not taken me a long time. So that's going to be another, I'll be revealing that at some point as well on the channel. But the code's way too complicated just to jump in. I was already halfway through it when I decided to start a channel up. Anyway, let's go back to our sprite and try and display that on there. So I'll get rid of that. As I say, we are using these tools that I've shown you. We're just going to use them, and I'd suggest you do the same to start with. You can copy this, or you can download it. Put a link. There's a GitHub with a load of junk in there of mine as well. But by now, I think you've even seen it enough times to copy it if you really want to. It's not that much code, and then we're going to learn how to use it. So what I've done is this is the part I created. I mean, I created this as well, but with a lot of help. This now just needs to know, right, it just needs, that's delete, this is draw, so it needs to know where the bitmap is. It wants a pointer to the bitmap. I should write that, really. Pointer to, same with that, really. Pointer to, just to be clear. Okay, so all it wants is a bitmap in HL, and it wants IX to properties. That's where we were. Okay, properties are there. So it needs the first byte is it alive? That's just used when they're moving. You want to know whether to draw them. If you try and draw something off the screen, you have problems. So basically, when it hits the edge of the screen, you set it to not alive, and that's a way around that. And then you tell it when to only draw things that are alive. Here's its X and Y position. They can be stored to whatever you want. Again, the size is important though, because that's how this routine knows where to, what to draw where. This one, as I say, is 2 bytes width and 8 lines in height. It's 16 bits across, 16 by 8. So let's draw it. Because we're not moving it, we could just draw it before the main loop as a test. and we'll make sure we include sprite tools and screen tools. I mean, I could have put that into sprite tools, include screen tools, but it makes much more sense to have it here in my opinion. Keep all of them there, and then have no includes in any of your other sub files. That's the way to do it, really. Because if you have multiple definitions, you're gonna find problems. I expect. I have never done that. Yeah, I know you would in C. Right, so we want to load HL with the bitmap. So it's as simple as that. Point HL. I like to capitalize that. Bitmap data. The bit that's not so simple is, yet again, I'm going to talk about the way the data is laid out. And in fact, let's copy that comment. Let's pop it there. Right, so now we've got face data. Let's call it player data. In fact, let's change face to player. Player sprite. Okay, so player data. I like to have it on another line, you don't have to. Is live, let's have 1 to represent yes. 0 would be no, but it could be anything. Again, your logic above will have to decide what that means. We're going to have 0, 0 for the location, position on screen. Size is in cells. Okay, cell is a whole byte, so we've got 2 cells width. That should be width, really, not size x. Height in lines, so this time is 8. Not 98. Okay. These are done at compile time, by the way. So you could just, it's not done at runtime by the machine. So it's done by the compiler. So you could write like 4 plus 4, or you could do 4 times 2 even though the Z80 cannot do multiplication. Because as I say, Pasma is dealing with that. So that's still going to be 8, which is what we want. And then we're going to load the IX register with a pointer. We're going to point the IX register in player data. Point IX at player data. Change it for face because it ain't called face anymore. It's called player sprite. And then draw sprite. But it's not just draw sprite. See, that's what I get caught out all the time because that's how you do it in some other languages. Like this is cool. Draw sprite. What that's going to obviously do is find this bit of code here, and it's going to go bang. It's going to instantly load B with IX plus 2. It's going to go, where the hell is IX plus 2? And it's going to go, okay, well IX is pointing at player data, plus 0 would be that, plus 1 plus 2. So it's looking at that value right there and popping it into B, the actual value, because you've got brackets. So it's not pointer anymore, that's the value going into B. Same with here, we're moving the X position into C. Then we're calling this mythical function, which takes them values and it spits out into HL, I believe, no, into DE. It spits out in DE memory address, which will be in the 20,000 region somewhere. You're gonna have to look at. I cannot show you websites on my stream the way it's set up, but there's a very good website. It's right in Spectrum screen memory. It's one of the top ones on Google. It explains it in just a couple of paragraphs. We'll look at that again another day. I'm going to set up so we can look at websites. as well. So anyway, with that in B and C, we no longer care what's in BC because it's been dealt with, but we do now care about DE. We can load B with something else, and B is often used as an iterator because there's a function which automatically counts B down and resets back to a loop, which we've used all the way down here. So that B value is the number of lines. So now we know, loop this 8 times and it paints each line. Yeah. Now if there was only one, if we were only 8 by 8, what we'd need then is just one. You know, this would be much more straightforward. This function here, we could just loop them 8 lines and put a byte in there. But because we've got 2, we've got to then go through this loop, the draw bytes loop. Now that takes A, puts into A the value that's in D, and the value in D is the high part of the memory address for the screen. It's comparing it to that value, which is where the memory starts. That's what I was referring to. You're going to look on the website. There's a table showing you where the memory starts for the screen, and that's where it is in the high bit. It then jumps if the value has gone past that. It jumps Z. That means is it equal? The Z flag. Remember I mentioned AF is a register, but you will never use F. Well, F stores the flags, and one of them is a Z flag. And if a CP, which is compare, that means compare. So you're comparing the value in A to that number, and then the result of that, if it's equal, Z becomes 1. And if that is the case, we're going to want to jump down to there, which means you've done that line and you can skip back. See, I wrote this bit of code, but it's quite mind-boggling how it works. All that's there for is to, in fact, that could be deleted. It's not necessary, but we won't delete it in case we cause problems. But you can ignore that. That there can be ignored, and that label even, because what that's doing is it's an attempt to, if this function tries to draw above that memory, when it reaches 58, it's not in the screen memory anymore, it's in the color memory. And if you go, you can have problems where if you try and draw something with too high a position or value, i.e. it's off the screen, you'll end up drawing into the color memory, and then you'll just get black marks all over your screen. So this was trying to avoid that, but I don't think it even worked for me. Aside from that, what we're really doing, I'm going to comment that I don't think it's needed. So pretend they're not there. So what we're really doing is we're loading A with the actual data. See, it's not a pointer. And we're taking the first bit of data from the HL, which was pointing at the face. So that's gone for that bit there. It then, this is a new one that you haven't seen yet. It's loading the data in DE. So DE was a pointer. It was pointing at a memory address. It had a value of, let's just say, hexadecimal 57 AA, for example. It would be in somewhere in that range. That value would be sitting in D. But because we put the brackets there, it's now going to find that memory address with that value and put value in that address, which is brilliant. That's what we want. It takes that byte and it puts it on the screen. That's what you need to know. Then we're increasing HL, increment, yeah, increment HL and E. The reason being is we don't want to draw the same bit again. We want to move to the next bit. The reason we're moving E is because E is storing the memory address. So that's going to actually move us 1 over on the memory address as well. which is obviously perfect. We don't want to overwrite on the screen memory, the one we just did. We want it moving along, and we want it in the next memory cell. That's why it's done that. The reason it gets complicated is obviously it needs to jump a whole line next. So once we've done that first line, we skip back. It should be going down another line. This could be heavily optimized. It doesn't all need to be here. It's quite confusing. We're going to write another one soon. When we got to get basics, we're going to write our own one of these again. Trying to see where this is called from. Right there. Yeah, so obviously we're simple. This DJNZ, which as I said before, that counts down a B and loops back to wherever this is, which is here. So that does the bytes, which is the sideways bits. As soon as that gets to 0, it ignores it. Look, B gets loaded again with the number of bytes width. Somewhere there's got to be a push B. Push B and pop. That's why. So that's pushed there. That B, that's saved to the stack. And we pop it from the stack. You have to pop everything you push. But it's another way of saving a value. We pop it back. B gets reduced by this function. We loop all the way back. And then we do the bytes loop. So we go boom, boom, down. Obviously, cool, next line. Boom, boom, down. Which all the down really means is it's adding 256 bytes. But as I say, it does have to take into account these oddly laid out cells, which we're going to have to talk about another time. You can't start off with that. Anyway, this is just learning how to make subroutines and how to use them, really. This is what we're learning here. This is a subroutine. And we're calling them here, yeah? This is what we're really learning today. The sprite just makes it a bit more fun. I think we're pretty much ready to go. It was literally that easy with this code here. I've highlighted this out, so it'll be interesting to see if this works. Save all. Go back to my correct folder. Alright. Write a command again. I'm glad that didn't compile because I spelt it wrong firstly, and secondly now you can see an error. So error on line 47 of fastfood.asm. Okay. I can't remember whether you need the backslash. Still don't like it. Let's just check my old file out. I know this one works. Util sprite. Oh, util. I don't think it matters if it's backslash or forward slash, but we'll soon find out. Okay, no, don't like that. Error in line 36 of sprite tools. For sprite. Oh, see, previously defined. What have I done here? I defined it there, put nothing on it. That was silly. Okay. In PowerShell, in case you wonder what I'm doing here, there's invoke item. I have to do that. I can't just write like, oh god, I called it fast for. Do you know what? Do you know what? It's easier just to call it f.tap, isn't it? Let's go. Let's do that. Oh, I'm an idiot. There we go. F.tap. Yeah, you can't just write f.tap like you could on command prompt. But what you can do is invoke item f.tap, and it'll just open it as if you were in Windows. Oh, we've got some sort of face going on here. What happens if I enlarge it? Oh, I can't see it very well. Very small on my screen. I'll make it bigger a second. Okay, so he looks a bit squat. Oh yeah, that's absolutely correct because we've only put 8 lines of height here. You know, so but let's say we want to turn him into a little man. You know, let's do that. Yeah. So down here, let's just copy all that. And as I say, this is the beauty of assembly language. You can put a comment here. It doesn't matter. It cares about where these bytes are, and that's it. You know, you could lay them out in whatever order you feel. You see, I have a space here. That's just to help me count how many there are. That's the only reason that I've left that space there. They're in groups of 8. Yeah, didn't need to be there or anything. Just letting you know that. I mean, you know, I'm not going to be a good drawer on this, and obviously use an art program. We'll be doing that very soon, trust me. I'm going to show you exactly how to export them and everything. I mean, for now, let's draw a very crude stick man. You know, we don't care really what this looks like. Alright. This is another thing I love about VS Code. Look at that, you can see the sprite. I mean, I know this is just, we haven't done any colour. We're not, you know, we're just beginning here. It's going to take some hours worth of watching before we get into doing colour and animations. I mean, we're not far off animations. As I say, what we've got, I mean, this could be an animation if you wanted it to be, you know, but you'd have to set your code up that way. But this way, this obviously, if we boot this game, if we compile it now, it's still going to be the same. It doesn't care about that other data. Exactly the same, right? But let's remember our data and change it. How many lines is it? Well, let's not mess about with this mathematics on here now. It's 16. And it's very, very wise to put that. That's a divider, that's something different. This here, you get into the habit of doing that before you, it's called pseudo-coding. You do things like that before you start. That way you can visualize how it's going to work. They're not laid out particularly great. I've done them without thinking, and added things to them later. But when I've got more experience, these are obviously for a more experienced, a more detailed game, there'd be more data as well. You'd want to know a few other things, number of lives, how much cash has he got, all that sort of stuff. But you'd lay it out brilliantly, and all your functions would work. So you'd be able to copy and paste from previous games and stuff like that. Anyway, the data's there, the format there, and we're still abiding by it. And it's gonna work. That's gonna be all we need. And there we go. It's a real crappy looking stick map. In fact, some of him, I swear his feet aren't getting drawn. One, two, three, four. That is odd. So I'm pretty sure it's got nothing to do with that space. Let's just rule that out. No, it made no difference. Why is he missing some of his bytes? At the bottom it appears. 2, 3, 4, 5, 6, 7, 8. As I said, that rubbish wasn't needed. But let's try it. Try having it back. It's completely unnecessary, and I'm going to delete it in a second. But unless it works now suddenly. No, makes no difference whatsoever. Get rid of that. That's how it should have looked right from the start. And that's code there I wrote, and I think it's pretty streamlined. Honestly, I worked on it for quite a while to get. I wanted to be able to print any sprite, any size, just by changing the values in here. I hope that's the takeaway that you've got. The takeaway that you've got from that. Because now, two very quick things, just to show you. Look, let's put him at 10x and 20y. So hopefully you'll be able to figure out where he's going to appear. $20y, because he's gone 20 down, 10 pixels to the right. Yeah, I think I've written it up here. I haven't. It's 32 times 8 across, so whatever that is. Yeah, 256 pixels wide. I think it's 192 for memory and height. So anyway, he's moved there. Let's just say we want to move him. If we want to, I mean, obviously we're going to do keyboard input, but not today. But let's say we wanted to move him. So now we're going to put it into the main loop, that code there. So every frame now we're telling it HL's that, and I set IX is that, and then we're asking it to draw the sprite. And a naive person would think, okay, that, you know, having studied the code here, okay, it takes the YX, so all I've got to do is change YX and it will draw it somewhere else. But you'll find there is a problem with that, which you'll see in a sec, because we'll draw it, but before we draw it, we could load IX1, IX plus 1, that's the X value. Sorry, not load, increment. I'm not sure, most things don't let you ink. Not everything does, sorry. I mean, that's a value there we increase. It's very good that the IX register lets us do that. You'll end up learning that a lot of things you try don't work, and you end up having to load it with a, you know, load a IX plus 1 ink a, you know, or add a, that would double that value, and then you'd load it back into IX1 back to A, so therefore you've just doubled the value in IX1. Yeah, that's great, but that's a lot of instructions for your processor. The 1980 processor to handle doesn't handle as much as you think it does, even though there's 3.5 million T instructions, T states per cycle, or per second, sorry. Anyway, I believe this works, so you can just literally increment IX1 directly like that. Hopefully that makes sense. Let's see if that works. Let's see if it at least moves it. And there you go, he's moving like a good one. Too fast. And he's not been deleted, as you see. Now, a naive person, myself included, would think, well, that's fine. We'll just clean the screen. We'll clear the screen like we do. Oh. And we'll do that at the start of every frame. And Bob's your uncle. Don't need to worry about deleting sprites. Why do these idiots bother with that? And that's great, but oh, look how slow he's moving. And also, why is he flickering? And that's just the way it is if you try and do that hacky way of fixing it there. It doesn't work. You can't do it, unfortunately. So we'll delete it and we'll think of another way. But also, did you notice how fast he was going? We haven't got any halt instruction. Halt there. Waits. If you imagine an old TV, it used to draw lines very fast across the screen. Then it would get to the last line and it would have to skip all the way back to the top left of the screen, ready to draw the next frame of the picture. Well, halt waits until that moment so that you can write all the data in that millisecond where it's going up to be back at the first one, so before it draws anything. And again, it is quite hard to understand. I'm still don't fully understand it myself, but this basically essentially one halt statement in a loop will mean you're running at 50 hertz. If I was drawing in loads of stuff and it wasn't achieving all of it, you'd see at the bottom some of the stuff was flickering or even not being drawn. That's because there's not enough time and it reaches another loop and tries to start all over again. But you can put another halt in there. So and then you're now running at 25 hertz or frames per second. You know, that could also be put down as, which is okay for a Spectrum game, to be honest. That's okay. And in fact, you can actually get away with one more if you need it. And you're going to be running at, I think, 17 FPS at that stage. You don't want to go any lower than that. But on an old system like this, that's actually okay. It's fine. 17 is fine. So is 25. You've got to bear in mind with your timers and stuff when you make them. So anyway, let's see it at 50 Hertz now, rather than super speeding. There we go. So now it's getting incremented one time. Seems a bit slow actually. Do you notice it comes down here as well? That's the way the spectrum works. If you let it go all the way across the side and loop, it's going to go down one. But then because of our positional variables, as I call them, the data, it's obviously getting set straight away back to where it should be. Okay. Back to my sprite tools tool that I wrote. It actually has a delete sprite function. It's very similar to the draw sprite, except for it does X or A. It doesn't need any pointer to the bitmap, because instead of finding the data in the bitmap, it just X or A, which makes A0, puts that in there, and that's it. It's the only difference. So what we're going to do is call delete sprite, and as long as the IX is there, and I don't think IX gets modified, no, because if you found IX modified in this section, you would then have to do that again before you call a draw sprite. But the way we haven't modified the X pointer, we're only modifying the values inside where the pointer's pointing to. So this is going to work, I believe. And there you go. I'm struggling to see why he's moving so slow. I did expect him to move a little faster. I wonder if it's because we're doing ink. That might actually use a lot of might use a lot of system. I don't know. I'll have to look it up. But let's try going to LD. I can't see this making it faster really. So we'll load it into A, and then we'll do ink A, which I know is quite fast. Let me comment it just to, in case you're really struggling, if you're not understanding. A now equals value in IX plus 1. Increment A plus equals 1. A equals X plus. Set new value into IX plus 1. Draw sprite will look in that same place and find that it's got a different value and therefore move it. That's why you call delete sprite, then you move it, then you draw it. It's very important to learn when you draw things, as opposed to updating them. I mean, deleting it's part of the update cycle, I guess, but the delete has to come first. If you move it before you delete it, obviously you're going to be left with the sprite you drew the previous frame, and then you're going to delete the one that you draw, but you're going to draw it afterwards, so you'll end up achieving nothing. But this code here, let's see if it runs faster, just out of interest. I think my brain's just too tired because I think it's running at correct speed. But seems quite a big step for the. I would have thought this was the minimum size step. For example, though, we could add a variable here, 4, and then we could say, okay, we've got speed, move speed. I like to not put a space for some reason. I'm a bit weird like that. So now we've got ix plus 0, 1, 2, 3, 4, 5, and ix plus 5 is the character's speed. So let's delete that old one. I'm just wondering whether you can do add. I think you might be able to do add ix plus 2. Oh no, you certainly won't actually. Let me undo that because most of the code was written. Oh sugar. Oh god, what have I done? I've lost it, I think. Okay. LDA ix plus 1. That's the x. That's the character x value. And then add to a ix plus 5 character speed. Add speed. Now put the new value back in to ix plus 1. So we've loaded a with x value. We've then added a with a speed value. Then we've loaded the x1 value with the value in a. So we basically took it out, added 4 to it, and put it back, and then drawn again. So we should find now, after save all, compile. Whee! He's moving around like a good one. Just checking my notifications, just in case anyone was trying to contact me. As I say, we're going to get a lot more detailed than this, and a lot more structured as well. I'm just testing out my stream here and getting used to how it, setting up the screen, and I haven't really thought about what I'm going to teach or show you or anything. And as I say, I am a beginner. This is like a beginner's course for beginners by a beginner. But I've managed, in case you weren't here earlier, I will show you the other game I made. I'm working on at the same time. We might skip back into this on the channel as well. I don't even need to load the code. Let's just load the game. So we're going to make fast food today. I don't know how far we're going to get, but this is another game I'm working on for a friend. In case you didn't see it, this is actual. It's got its main menu. Look. Can I zoom? Oh no, I can't do that. It's got some fun effects. We'll be working through this. I'm going to choose WASD keys. Be prepared for some really horrible music. Okay, back to our game then. Back to our game. we'll set up two constants. Player start x db. Where do we want him to start? I mean, I want him to start at the bottom middle of the screen. So the middle of the screen is, can't remember exact, 16 times 8, 128. So that's roughly middle. Obviously, he's going to be a bit off center because that's going to be the top left of his sprite, starting right in the center of the screen. The y value, well, 192 is the actual bottom of the screen, but we need to take away his height, which is 16. Same with that, we'll just take away 8. Now he's going to start in the middle. He also, it's going to be just a face. He's not even going to have the body. Which means I've got to change. I'll change that. And I've got to also change that. Right, there we go. So I mean, it's not a powerful language like in C, C++, C Sharp. I'd be creating properties and fields for all these. I'd be able to make a collection, lists, everything, and you know, you could iterate through things and spawn enemies much quicker. This is quite tricky to. You have to really think about it, and you do end up copying and pasting or remembering where things are to change, because otherwise, if you use too much processing power looping through loops, you'll find the game won't run correctly. You need to actually brute force code a lot of the stuff in. Right, next thing we want to do is some keyboard input, but firstly I'm going to set the character, put them constants above. You can use a constant in here, that's not, shouldn't be a problem. Let's double check if that compiles. It's always very much worth checking that it compiles. See, we've already got some major problem here that I've created. I think that's just because he went off the screen. Oh dear. It's not liking that constant, is it? I don't know why. I'm sure I'll figure it out later when I'm not on the stream. It'll just come to me. There we go. It works great now. Right, well, the next logical thing we need is probably some keyboard input, right? And be able to move him left to right. Luckily, I took a note of the memory addresses we need to worry about. There they are. I like to put these comments on my screen in all my files. Doesn't really hurt. It uses a couple of kilobytes, you know, not even that. This is your memory addresses in hexadecimal for where the keyboard ports are. They all default to 1 every bit, and if it's a 0 it means the key's being pressed at that location. So we could do something like, I mean, again, I've got it written already, but we'll rewrite this. Check key input. I always comment your code. I haven't been doing that work that much here, but it's very worth it when you come back to it. This function is going to check for key presses and call movement on character when press detected. Alright, so now I know when I come back to this in 3 weeks time or whatever, and I say, oh, why, you know, this just says check key, it doesn't say it's going to do any movement, but now I know it does. Trust me, it will help you greatly doing that. Mine goes blank when you're streaming. I'm telling you, when I'm not streaming, I'm just bubbling away, getting the code out. I mean, what you want to do here is just load any register really with them values, one of them values. So we're going to use A and D for left and right, okay? Because they're both on the same register. Not register, in the same memory address byte. If it's 5, could have fitted 8, but if it's 5, and that's made by ZX Sinclair Spectrum. You can't change that. Well, I mean, not easily. Check keys. So we'll load it into BC. Doesn't really matter, but HL was a bad choice because that can be used for additions and adding it to itself to multiply and stuff like that. So it's not a pointer, we're just putting a memory address into BC. And there it is. What we want is the first bit 0 of that. That's an input command. So we do tell it input. It's not inc, it's input. Get the input in A from C. These comments aren't always essential, but it's good for when you're learning. No, I'm going to leave it nice and clear. It says up there what it does. This is where you need the RR. Is it RR or RRA? RRA, yeah. What you're doing there is RRA rotates the bits values right, but it actually keeps in the carry bit of F what the value was that you rolled away. And that's actually the one we're interested in here. So key 0 equals A. So now we've just like rolled the bit for A, and if that is value 0, then we know we've got to press. So you push it, and then this is where it's a conditional thing. You've got to check the carry bit. If the C flag is not set, so NC, not C, then you know that button has been pressed. Like I said, it's a 0 when it's pressed for some reason. You'd think it was a 1, but it's the other way around. and then we'll move left. Always have to pop it back, otherwise you get a memory overflow, memory leak. And RRA key 1 equals, well, this is an uninteresting key because it's S. So we'll put a comment, call something that, well, we'll even put call NC to remind ourselves. Something that S does. S key does. Probably won't ever use that, but anyway. Of course, we're meant to push AF again. Pop AF. That's just pushing it and pushing it to the stack and getting it off the stack. The stack is just a piece of memory on the computer, but it's a stack, hence the name stack. So you can only get the top piece. That's why you have to get them in order. If you push something, you've got to get it back before you push something else. Or if you push something else, you've got to get it back in the right order. Anyway, so the final rotate right for key 2, and that's a D. Push AF, call NC, move right. Pop AF. Now this is a function we're going to call, so it's not part of the main flow, so therefore it needs a return statement so that it goes back to where it was when you call a call. But as you can see, it's checked the key. If it's found a 0 in a certain bit, we call a move left function, which we're going to create now. And same for move right. We already made a move. We already done the move code earlier. We know how to make that. It could probably be optimized, but it doesn't need to be for this scenario. We want to move it by speed, so we'll do load A. We'll get ix plus 1, which is the xpos. Get xpos. Add a ix plus 4. I think it was 5. Add speed. But we want to move left, so it's actually subtract. And that's it. We'll put it back in there. That's all it needs to do. Set the new value to xpos. You think that might be it, but you're going to have to learn one more thing first, because if it goes off the left of the screen, you're going to have trouble with the memory because of the way these draw functions work. Now, a very easy way and a common way to get rid of that is just to not let them go off the screen. So, and if they do, you have to remove. This is what the isAlign is for. You change that flag, and therefore don't draw. You'd have to put in your draw code, a comparer. Is it alive or not? And if but this is what we're going to do now. But what we're doing right now is we're going to compare, is it at its absolute left point, which happens to be 0, so let's not mess around making any variables. We can just do XOR A, make A equal 0. And then, well, actually, that's probably not the best way of doing it, because that will involve loading an IX unnecessarily. So we'll do load A, because compare only works on the A register. That's why I've done that. So instead, we'll load in xpos I'll comment it again. Compare 0. Compare is A equal to 0, or compare A with 0, because it didn't. I wish I could show you the flags website now, but I can't. But you're going to want to look it up. The reason, if I put ret z, that's return z. This means, is the z flag 1 or is it set? A bit is either set, which means it's 1, or it's reset, which means it's 0. The return with this conditional statement means return if they are equal. That's what means a z flag will be set. There's other flags for if it's more than or equal, or if it's less than. That would be the C flag or the NC. We'll have to slowly read about it. We're going to learn these things, but return Z basically means, is it equal? So is A equal to 0? If so, return. Okay, so now it's going to call move when you press left, but if it's already 0, it's going to return, so you're not going to move. But after that, after a conditional one, it will skip to this and it will let you move. Let's do the same for right. You can copy and paste a lot of that. Okay, this time it's not 0. I tend to make a constant for this. Max x equals, oh sugar, they should have been equal. No wonder it didn't work earlier. That's the reason it didn't work earlier. Max x equals 2, I think it's 256. Let me double check my maths. 32 times 8, 256, yeah. Take away 16. There we go. The problem is we don't want to check if it's equal, because if there's speed involved, which there is, it could go over that. So instead we could put a buffer. Let's just say 25, right? And now we want to know, if we're moving right, we want to compare it to max x. Compare A with max x. But this time we don't want to return if it's equal. We want to return if it's more than or equal. I have to look it up myself. Basically, I go to Z80 Heaven CP, which is the instruction we're using, and it will tell you all about it. find out if it's more than or equal, the C flag is reset. So NC means more than or equal. My keyboard's junk. So I hope you understand that. Max X is the side of the screen on the right, take away a small buffer, which is bigger than the player's width plus speed. And if it exceeds that value, we'll return and we won't move right. If not, we will. I'm expecting this to work now straight away off the top of there, off the bat. So let's try it. Oh, okay. Line 53 of fast food. With sub, you can only sub on A, and you don't need A. It's weird though, because with add, you do need A. So, in my opinion, they should just let you need A for sub as well. It's the compiler issue with that. Some compilers might allow it. Oh, 62. Same thing again. Oh, it's lucky that happened because we want to increase speed. Increment. Oh, still nothing. Oh, I didn't save. And there we go. It doesn't work. Oh, wait. This is always what programming is like for me. Oh wait, I forgot to write that there. Check key input. That's it. So we've popped IX in. Does check key change IX? No, nothing changes IX. Change HL. Nothing even changes HL, so we can in fact leave the HL there. But quite often you'll end up putting that in above each one of these calls. It doesn't always remain. In fact, if it doesn't work, that's probably what will be the cause. You can push and pop as well. And there we go. Oh, it's not moving right though. Moving left but not right. Why did I add? Ink. It's add. Too much talking while I do. 63. As I say, with add, you have to specify the A because you can't add HL. It's just annoying that on sub you don't need to, really. They should make it so you do. I forgot to save it again. Really am talking rubbish. And there we go. It's compiled. I can move. Not bad. Pretty good. I mean, I think I demonstrated to you that sprite could be anything. You know, that took 5 minutes or less to make just by pressing the 1 and 0 key on the keyboard. Didn't have to do any mouse work or anything, you know. So just bear that in mind when you're looking at this. That sprite could be anything. You could spend hours making a wonderful 64 by 64 sprite and it would work. Although that's getting a little big because you're going to put some strain on the hardware. But like 32 by 32 or 24 by 24, you can make a very rich looking sprite. As I say, we'll colour in one day, but at the moment I'm working on black and white. The colour I find does get quite complicated. It doesn't always work when you think it's going to because you run out of processing power. So you don't know whether it's your code not working or or the machine itself. What we really want is we want to create some fast food now. I'll do a little longer on this video and then we'll wind it up for the night. The videos will become more organised as I go. I'm brand new to this, so brand new to streaming. I've been coding for years, but I'm pretty new to retro assembly coding as well. So yeah, I'm trying to set up my screen. Jesus. Right, I'm just being a bit OCD now, isn't I? The fruits, burgers. Next time I'll have to come with some art prepared because I can't imagine anyone watching this. It's a burger sprite. I mean, I don't even care what it looks like, to be honest. For now, just to get it on the screen and falling down. Then we'll do collision detection tomorrow. XOR, for example, would change all of those to be the opposite. And it's another use for XOR is you can have an overlay. It does help stop flickering when you go over background images. You can replace the background with an XORed version of the sprite. It's much more advanced than what we're doing here, but not that much more. Once you get started, as I say, you get these breakwater moments, you know, where you suddenly understand a lot of it. It just kicks in. It's just a case of doing it. I mean, this burger's nasty, but it would do. Looks more like a ninja, I think. With them zeros. I mean, there is going to be some gaming on this channel as well. I've got a bit of Tetris coming up. I've got my best score is about 250,000, so not the very best, but that's on an emulator as well. So we'll, you know, I'll see a bit of Tetris on here later. Probably might even be some before I go to sleep. I do play lots of other retro games as well. I'm a member of retroachievements.org. I'm actually a developer there, and that I really enjoy. If you're into retro gaming and you haven't found that website, go find it, because it links into your emulators and gives you achievements. It's like having Steam but for SNES and N64, Mega Drive, Game Boy. It's got everything. So check that out, retroachievements.org. Sorry, I'm just rolling a cigarette. This is why I'm pausing. What are we doing here again? I forget. Oh yeah, we're going to try and make... See, it's like scratching a... It's like putting a tip on an iceberg in it, because I can draw the burgers, right? But if we want to spawn them randomly on screen, that's going to take quite a long bit of setup. It can certainly be done. I think let's work on that. Let's work on the random spawning before we draw it. We know how to draw sprites now. So, I mean, I'd normally split all this up into many other folders, files. I like to split things up. Some people like to keep it all in one file. It's not very big at the moment, but let's have random number. Again, you always want to comment code if it doesn't explain, because you'll never remember otherwise. If it doesn't automatically explain it just by looking at it like this one does, then comment it at the top. So this one is going to put a random number into A. Okay. It's going to do that by, it's going to step through memory. Step through. It steps through action. This is like a hacky way of doing it, but it's known in the Spectrum world as quite a good way, a fast way of getting true, well not true random, but very nice random number. Steps through the Spectrum ROM routines, you know, ROM memory of the actual computer memory, you know, the OS if you want to call it that. Yeah, I think that says it all. It steps through ROM memory, gets a random 8-bit number. That'll do. That's enough. So to do that, we're gonna need yet more data. Not much. We just need one bit of data called a random seed. And that's going to be a 16-bit number, a word. They're called words. That's 2 bytes, 16-bit. It can just be 0 for now. And what we're going to do is we're going to load HL with the value of seed, which is 0. We're going to load A with H. A can't take HL because HL is 16 bits. A is 8. Here's your first bit of the AND bitwise operator. It's called AND. You do need to look these up eventually. They're not hard to look up. You know, there's not that many of them. Check out the site Z80 Heaven. It explains them very well. But what that is saying is, it takes the number that's in A, the binary number, which all numbers are, and it takes it. It looks at all the bytes, and they both have to be 1 for it to be 1. So now we're only going to, all of them bytes are going to be 0. In fact, I've done this the wrong way around, and it should be the other way. If you look up on a program's calculator, which you should have built into Windows, you write the number 31. That's a decimal number, hexadecimal 1F. binary representation of that is 3 zeros and 5 ones. So now, if A has a value higher than that, it will always become lower, because them bytes are going to be 0, and that's only on the upper part of the HL. So our address, I mean, it's 0 anyway right now, but you know, it won't always be 0, as you'll see in a minute. So now we want to load H with A, put it back in. So all we've done there is we've make sure HL is smaller than or equal to 8K of ROM, which is 8092. The reason for that is memory after that 8292 is predictable, and therefore using this technique you're going to get the same numbers all the time. So this way you won't get the same numbers all the time, they're going to be different. They're constantly changing between a value of 0 and 255. What we've done there is we're now loading A with the value inside HL. Before we were changing the address of HL. Now we're looking in there and we're getting the value. So what we're actually doing is get the random number from where HL was pointing, or is pointing actually, still is pointing there. Now we're going to increment it. So that we don't get the same value again next time. And then what we're going to do is tell the seed to be that, the value in seed, yeah? So it was 0 at the start of the program. And it's now a much different number to 0. I mean, it only goes up by 1 each time, doesn't it? But this is happening 50 times per second, so well, it can, or more than that. Anyway, that's actually all you need. That function, that'll serve you well in a lot of games. You can make a lot of use of that without recoding it. And this is where things are about to get tricky, because we'll need, I mean, in another programming language, you could easily make a list or an array of enemies or burgers or whatever you want to call them. And you can't do that in this, but what you can do is it's even more wonderful. You don't need an array, you just create one right here. So where we've created player sprite, for example, that's an array already. But this time we're going to want something similar to that, because we're going to want to draw these burgers just like we're drawing the player. We don't want to have to write another function to draw burgers just because they've got different data structure. So we're going to keep to that, and then if we need any more we can just add it to the end. But we'll do burger data. Well, in fact, it won't always be a burger, right? We'll do food data. Define a byte. Every time you do a new line, you define byte. You don't need, if not, it's just a comma. But we'll put is life to 0, because we're going to have more than one of these, and we're going to spawn them randomly, so they're not spawned right from the beginning. Player is alive right from the beginning. We've got no menu, we've got no nothing. Don't even worry about that. I mean, obviously that's too basic, really, but it's good enough for this simple game. Food data 0. These can all be zeros because we're going to procedurally set them. The width, on the other hand, isn't. It's the same as the player. So it's 2 bytes wide and 8 high. Move speed doesn't actually matter. It doesn't get used in the drawing code, but we're going to put it in the same place anyway. Let's have a move speed of 2 for now. Again, this is going to be procedurally changed because as the difficulty goes up, you'll want to increase the burger speed. It can all be changed. This is the default. But not just that, we'll copy and paste this data format, post it there, because we're going to add in type. And then to be really clever, we'll put 0 equals burger, 1 equals what would he not want to eat? Let's do apple. So that's a bad one. That's a good one. Obviously you'd have loads more really, but we'll leave everything in the burger for now. So that is one piece of food we've just defined there. We might have a maximum of say 20, let's say 10 on the screen. Let's say 5 because we don't want a big long code. Let's say the maximum you can have on the screen is 5. Okay. So now we've got enough capacity. We've got capacity for 5 of them, no problem. But it doesn't do a lot right now. Going to need to write some much convoluted code to spawn these randomly and to make them alive one by one, and to kill them when they reach the bottom of the screen, and obviously if they collide with the player. For now, shall we just say, how should we spawn them? What should be the condition? Should it just be time? It's been a long stream. I think I'll call it a night here. I know no one's watching anyway, so I'm going to check it back and make sure it all worked. I won't change any of this code, but I'll have a think about the best way to spawn, what conditions we should use to spawn these enemies and these power-ups. We'll also add a HUD, some animations. There's going to be loads of stuff coming, don't worry. I hope someone watches this. When there's live viewers, it will be certainly much more fun because I'll be keeping an eye on the chat, and we'll work on it together. We'll add things that you suggest. Loads of it won't work, and we'll figure out how to get it working. It's going to be all good fun, in my opinion. And then we'll follow it up with some gameplay of some NES classics and Super Nintendo, Sega Mega Drive, Commodore Amiga, everything really. Let's get it going. Have fun, guys. I'm going off to sleep. It's very late here, but I've enjoyed myself. I'm going to only improve. I know this stream's been pretty garbage. It's a learning curve. So thanks for bearing with me. See you soon.